Okay, so for this circuit we have to find V naught here, which is unknown, and the current through 30 ohms resistance, which is IA. So these two we have to find. So first what I will do, we know the voltage source here. I will try to find the equivalent resistance of these ones, and then I will use voltage divider rule to find the voltage drop here. So when I want to do that, equivalent resistance of all these three branches basically. So first let's do minimize first the last the rightmost, these two. So this is 30 ohms and 50 60 50 plus 10, these two are in series, so that will be 60 ohms. So 30 ohms, 60 ohms in parallel, 60 ohms and 30 ohms, and the equivalent value will be 30 times 60 divided by 30 plus 60, which is 180 over 90, so 20, sorry, 1800 over 90, so 20. So 20 ohms, that's there. So I will redraw it, probably that will give some sense. So oops, there is a 70 ohms here which I missed. 70 ohms there, and this one is now just 1. So that's now 20 ohms, and this is also 20 ohms, this is 40 ohms, and this is 70 ohms, and this is our 60 volts. So again 20 and 20, these two parallel combination we have to find, and since they are the same, we know the parallel equivalent will be half of the value, so 20 over 20. So I will just still do it, 20 plus 20, so that gives us 10, 400 divided by 40. So we have now just one series circuit, which is good, where we can apply our voltage divider rule. So that's 10 ohms, and this is 60 volts. So since we are interested in the voltage across 40 ohms, V naught will be total voltage divided by sum of all the series resistances, 70 plus 10, multiplied by the resistance across which we want to find the voltage, so that one. So this one gives us 2400 divided by 120, so V naught becomes 20 volts. So that's the voltage drop across 40 ohms. So we need to find, the other thing we need to find is this resistance, the current through this resistance. So we have to go back to the original circuit now, at least not quite the original circuit right away. So let's do this circuit first, because what I will do, I will try to apply current divider rule. So if first I want to find the current through this branch, which will be again divided between this branch and this branch. So in order to do that, what I can do first is just find the equivalent resistance, this one. So if we call it, let's say IX, maybe we want to find IX. So when we want to find IX, we need to have the equivalent value of these two resistances. So this is now my IX, which is of course goes through a branch that is equivalent of those two branches, and it is not the current that we want. We want this current, but in order to find that, we need to find this current first. So we also don't know this current yet, but we can find now, because we know the voltage drop across it, which is 20 volts. So current, that current, I don't know what shall I call it, maybe IA. So I'm just randomly naming them. IA will be 20 divided by 40, because it's 20 divided by 40, so that's 0.5 amps, or I can say 500 milliamps, I don't know, maybe I will write that. So this is volts, this is resistance, so current is 500 milliamps, so that's fine. We know now IA. Since we know IA, we can apply current divider rule. So this current IA will be divided will go through this branch, and this branch, part of it will go this through this branch, the other part will go through that branch. So but these two resistances are the same, we can see that. So we actually don't need to do the current divider rule. So we can just see that the current will be divided equally. So we don't have to do that, but I will still write the expression for the sake of it. So that's what did we call it, Ix. Okay, so Ix equals to, total current is 500 milliamps divided by 20 plus 20 times the branch through which we want to find the current, which is 20. Both are 20, so it's becoming, of course, 250 milliamps. So now we know this current, this current of course will be also 250, but we don't need that. So we know this current. Now we can go back to our original circuit here, and then we have to apply current divider rule once again to find this current IA. So now I'm not sure if it's better probably if I draw the circuit again. So this, and then I have this one, and then I have this and this. So this is my original circuit, which is 60 volts, 40 ohms, 70 ohms, and then this was 20, I guess, 20, 30, yep, 20 ohms, 30 ohms, 50 ohms, and 10 ohms. So now we know this current, which is Ix, and that is 250 milliamps. Ix, we know that, and we need to find Ia. So Ia will be, we will apply current divider rule again at this branch, at this junction, sorry. So total current, which is Ix, divided by sum of the two parallel branches, which is 30 plus 50 plus 10, times the other branch. So we want to find the current through this branch, so we have to multiply by the resistance of the other branch. That's what we do. So 50 plus 10 together, so I will just directly write 60. So this is becoming Ix is 250 divided by 30 plus 60 here times 60. So that's 250 divided by 250 times 60 divided by 90. So that's becoming this is, this is 3 and this is 2, so 500 divided by 3, so that's 166.666 or 67 milliamps. So that will be the current. Since this is in milliamps, this will also be milliamps. So that is the current through 30 ohms resistance in our circuit. So we have applied both current divider rule and voltage divider rule to solve this problem.